Uh, Welcome everyone to this class. I hope I am audible enough, and let's wait for the next five minutes or so, 5 to 10 minutes for everyone to arrive, and then we can begin this class. Four more minutes, and we can start. Around 2 more minutes, and we can start as we wait for the others to join us. We will begin. One more minute, and we can start. The others will have to join as we move along. We are about to start. We are about to start. Okay. I believe we can start now, and I hope I am audible enough. And welcome to the first of many classes on the greatest fear of many programmers, data structures, and algorithms. And I'm going to center most of my classes on Python. But don't worry, even if you're not a Python guru and whatever, you can ignore the code side, but the technical and the node side will apply to any other language. I'm just the how is it called, practical implementation. I'm going to show it with Python, and I believe we can start now. Anyone else who's late to the class can join later as we move along. So this class, we're going to cover just such algorithms, but I am going to introduce algorithms as an whole and then go on to discuss such algorithms. And I believe you can start with the algorithm definition and introduction to it. So, what is an algorithm? An algorithm is a step-by-step procedure to solve a problem or perform a task. An algorithm does not have to be in code. It can be in your life, how you order your life, your schedule, how you plan every step of the day that you do. That's an algorithm in itself. That's what it is, a step-by-step procedure to solve a problem or perform a task. Now, in programming, algorithms are used to solve problems or automate tasks in a systematic and efficient manner. Simple. An algorithm has to be very systematic. It's not willy-nilly where you do something because you want to do it. You have to be ordered in a certain way, and it is the main reason you use algorithm is to be as efficient as possible. That's why you use them, not just going or just doing it randomly. They are a set of instructions or rules that guide the computer or software in performing a particular task or solving a problem. You could write maybe an algorithm to add two numbers together, to divide, to multiply, and then you put them together to form a calculator. I put an algorithm to sort a list, to search for a number in a list, search for a number in a graph. All of these are algorithms, and we just write them so that you can tell the computer to do something in a particular way, in a particular pattern, to go and solve a problem or perform a task. That's all algorithms are. They're not that complex. You write them all the time without yourself knowing. But in this course, we're going to really concentrate on such specific algorithms. Now, for today, we are doing such algorithms, but we have three of them here. We have sorting algorithms, where there are many like bubble, insertion, and there are very many. And the algorithms used to sort data. Maybe you want numbers to be from ascending or descending order. Maybe you want letters to start in alphabetical order. All of those are sorting algorithms that you might write to do that specific task. Then we have search algorithms. Simply put, search algorithms are for searching a specific value, maybe a number, maybe a name, maybe a letter, maybe a value. Just searching them from a list from anywhere. Those are search algorithms, finding a value or record that the user demands. Then you have graph or pathfinding algorithms. This will be very later on in the course, and this will be very complex. And I doubt I would do these algorithms without covering their related basically I won't cover them until I teach like graphs and all that. So don't worry about them right now. But a graph and those, they're just used to find solutions to problem like finding the shortest path between cities and real world problems like the traveling salesman. We are going to cover all these problems in a far off course, so you don't have to worry about that. So you have said that this class we're going to search algorithms, and you can start, as you have said, is for finding an element or a value within a collection of data. Here we're only going to discuss two such algorithms. Don't worry, we have hundreds of such, okay, maybe not hundreds, but we have very many such algorithms out there. But in our day-to-day and career basis, we're only going to really encounter most of the time linear and binary search. So those are the only two I'm going to cover: linear or sequential search, or binary search or interval search. Some people call it interval search. And you're going to cover these two today. I hope you're ready, and we can begin on the first of these search algorithms. The first one is linear search. As you can hear, it's linear, straight on. It's a simple algorithm that checks every element in a list sequentially until the desired element is found. What do you mean by sequentially? Basically, you're going to start at the first one, going on until the end. No skipping, no nothing. You start from the start and move on to the end, one by one to the end. That's why we call it linear. It's on one path, direct, equal steps used. That's what is called linear search. And something you have to understand as you're learning this linear or this search sorting and graph algorithms, you'll have to understand the steps included in solving these algorithms. How do you do these algorithms? You need to understand the steps, each and every step. It's very essential because once you understand these steps, you'll also understand how easy it is to implement them in your code quite easily. So how do we do this? First of all, we have to start from the first element. As I said, you start from the first element. Now you compare each element of the list with the target value. So if you are starting at, let's say we have number 1, 2, 3, up to 10, maybe they're randomized. You start at the first position at index 0. You know we are programming, we start index 0 to number 1. At index 0, you compare. Is the value at index 0 equal to the target value? That's the first step. You compare. Now, if it matches, you return that index. The value of that index, you return it, or the index itself, just return that index. Maybe it's at index 0, you have compared and they match. But if it's not found, you have to iterate through the entire list. So if index 0 does not match the target value, now you move on to index 1, and then you compare again with the target value, and go on, so on and so forth, until you get to the end of the list. Now, one thing I should have written here, if you don't find it, return maybe false or not false or 0 or 1, basically a value to indicate you have not found it. But if you do, you can just return -1 or 0, whatever value to indicate that you have found it. Now what I'm saying, one thing to note when you're talking about linear search algorithms, and also cover this in the binary search algorithm, is that linear algorithms have the advantage that they can work on both sorted and unsorted lists. Sorting algorithms we'll cover later, but what you have to know is for linear search, they work both on sorted and unsorted lists. That's one of their biggest strong suits. Now, we will cover the implementation in Visual Studio after this slideshow, and I'll show you how to implement linear search on Python. You can follow along as I do it in Python, but don't worry, the same way I write in Python, it's the same it could be written in C++, in Rust, in whatever other language, JavaScript, it will be written in basically the same format. So I'll cover on later how to write it down in Visual Studio or in Python itself. And I believe there's someone whose microphone is on. Philip, it may be causing some disruptions, echoing, which is returning back. I would appreciate if you turn it off. Thank you. Okay, now let us begin on one of the more complex search algorithms. It is the complex of the two, binary search. It's an efficient algorithm. That's something you should note. Binary is more efficient than a linear. It's an efficient algorithm that works on sorted lists. That's something to note. Works on sorted lists by repeatedly dividing the search interval in half till the value is found. We have noted something. We said linear algorithms only work linear algorithm can work in sorted and unsorted lists. But the binary search in itself, though or with all its efficiency goodness, only works on sorted lists. Now, let's go through the steps of conducting a binary search. First of all, you have to start with a sorted list. That's a very important part. You can't start with a random list because it's not going to work as well as you believe. Because you'll be comparing a lot, it's good to have a sorted list first. Don't worry about it. We'll cover sorting algorithms. And after we cover sorting algorithms, we'll go back on binary search and try to implement it together with the sorting algorithms. But for this class, we'll use a list that is technically already sorted. Secondly, we need to compute the middle element of the list. When you divide by 2 plus 1, just find the middle element of the list. Don't worry, I'll show you the implementation of this in code. Now, if the middle element is equal to what you're looking for, you return its index. It could be done there, but most of the time it won't be equal. So, If the element is less than, you search on the right half. If it's greater than, you search on the left half. Now, this is why we told you it has to be sorted. Because why would you compare with the two sets which is bigger or less than the other if it's not sorted? What have we said? If that target value is greater than that middle element, if it's greater, obviously, it means that if the target is greater than the middle value, you look on the right side. Why do we say that? Because the target is of a bigger value than the middle position. Let's say it's from 1 to 10, and now we're using 5 as a middle element. We are looking for number 7. Now, if you compare 7 and 5, obviously 7 is greater than 5. You can't look on the left side because there's 4, 3, 2, 1. They are smaller than 7, obviously. So you can push away the left side and only concentrate on the right side. This is why we say that binary search is more efficient than linear search. It's because you are able to knock out more values at once than linear search. Now, as we have said, if the target is bigger than the middle, look at the right. If it's smaller than the middle, look at the left. Now you have to continue these steps constantly until the search interval is empty. It's to search until you have not found it, or you search until you have found it. You continue onwards to the same step. You continue dividing by half. You separate, go to the right, go to the left. Now you have another portion of the list. Divide that by half. Look at the middle point. Compare, equal, no, right, left, and you go on until you get a number that is equal or just find nothing at all. That is it. Binary search, it's a bit more complex, but when you understand how it's implemented, it's very easy. You have nothing to worry about. And as I noted, it is faster than linear search, obviously. Imagine this, you have like a big list. If you are doing a linear search, unaanzia from position 1 to 1,000, that's going to take a long time. But let's say you're doing with binary search. Step 1, you've already eliminated 500, you have compared, you eliminate other 250, you're skipping more at once looking for a single number. All you have to worry about, it has to be sorted. That is it. That is it. Now, we'll cover again the binary search implementation. I will implement it with a sorted list for now, but in the future, as I cover sorting algorithms, I'll ensure I come back to binary search, a short makeover to see how it's implemented through sorting and then searching. Now, it's good to compare the linear and binary search so you can know where to use them and where not to use them. So, first of all, linear search. As we said, it can work on both unsorted and sorted, by binary can only work on sorted. Note that. Time complexity, don't worry about it for now. That's a topic that very many people struggle with. That's a topic very many people struggle with. So don't worry about it for now. I will cover it. It's my next class. I will go after sorting algorithms. I will cover the time complexity and show you the ratio of time complexity per each search and sort algorithm. Now we go to efficiency. As we said, linear is slower for large data, but binary is faster for large data. In a normal sense, if it's a list of just 10 elements, linear search might be faster, but most of the time you'll be meeting in the world large sets of data, and at that point, binary search will be the way to go. And as implementation, linear is, as I said, it's quite simple. It's a few lines, but binary is just slightly more complex. Now, I hope you have gotten the theory part, because now I want us to go to the implementation side of things. If you give me a moment, as I open up Visual Studio Code, give me one moment. Second. My laptop is getting a little slow to open one thing. Give me 1 second as I share. Aha. I hope you people can see it now, can see what I'm working with at the moment. And for us, I'm just going to create maybe main.py. It doesn't really matter. It doesn't actually really matter the file name that I use at the moment. And now we are going to go through these algorithms. If you have some sort of laptop, somewhere you want to follow along, you can follow along if you want. But if you can't, I'll ensure that the recording of this video is able to get to you, and you're going to able to see what we have done. Now, we have our main.py here, and we want to write linear. Oh, I should even have called it just linear.py so that we do not confuse this file. I don't know. It should be now linear. So you can know what you are working with, and later we'll do binary. Now, for now, you're going to start as the linear search. Now, how do you write linear search? As we said, for linear search, we are going to start from the first element to the end. So what you're going to do, you're going to create a function that takes in a list. You're going to use a list at the moment too, because it will be a list of numbers, which use a list and a target value. So we are going to define, let's say, we're going to call it linear search. I guess also have an A for completion. It's good. You should have an A to complete your work. And then let's see. This searching, oh, it's streaming. Linear search, and then we are going to put in a list. A list, you can just put an empty one for now. It doesn't really matter. I just put a normal list name. You're going to replace it later. It doesn't really matter. And finally, you're going to have a target. Sorry for that. You're going to have a target value. Now, this list and whatever it is going to be the way we are going to go through this work. You're going to put a list in, and then through the list, we are going to use the target to search through the list from whatever number 1, 2, 3. Doesn't really matter. It can be anything else, and you're going to work through this. So now, what else do we need to do? 1 second. We need to create a for loop. While we're creating a for loop, we have to iterate from the first to the last digit, one by one. So we're going to create a for loop for I in range. Since we are starting at the first index value, which is now at position 0, 1 second, it's at position 0, and we're going to go to the length of the list. Simple. Ah, man, these things are covering my space. Now we have a for loop. It's going to start from index 0 to the length of the list. If the list has 5 elements, it's going to go up to 4, basically. Now, we are starting from 0 to the length of the list, which is 5. Now, if now the first digit, whatever, list at that position I, like it's going to start at 0, I is going to be 0. That means the first position. If at I now is equal to the target, this target you had put here, target. Now, what should we do? We should return the index of that position, as we said. But, but what if we just don't find anything? Well, the best we can do is just return none, because in the end, it's not there. So we can't really return anything if it's not there. And that's it. As I said, linear search is actually a very easy algorithm to get. That is it. It's something you could have actually thought of in your head and just written. Where we start at position 0, at index 0, move along comparing. If we find it, we return the index. If we don't, return none. Now, we would have a very easy time if we kind of verify if this works. It might not actually be working. Why am I kidding? It could be wrong. So what are you going to do? You're going to create a verify function. You don't have to write a verify function. You could just return the result. But I think it will be good if you write a verify function. So you're going to verify this with the index you're going to get. Now, if index is not none, If it's not none, you know it. We have found it, obviously. If it's not none, what do we do about that? We're going to print found it at and man. And where did you find it? Man. At index, this index. And I think it will be good we put a space here. Ili kuwe na space katikati ya index na whatever. Now, else, what if we got none? If we didn't find it, oh, sorry for that. If we didn't find it, we can just print look elsewhere. Why not? Doesn't really matter what we write because we just need to know that we have found what we are looking for. Now, we need a list to test this with. So we are just going to create a numbered list. That is it. We're just going to create a numbered list from, we can just randomize. It doesn't really matter. We're just going to randomize it as we said. Oh, I didn't notice. Never type quickly. Sorry for that. Now, where are we? I guess that's enough. We can now start to search anything from here. Now, let's test the result. What will the result be? It will be the linear search, and you're going to put the list of numbers and the target, which, let's say we are searching for 34. Why not? Because 34 is in the list, obviously. All you can do is just verify, verify result. And then that is it. Man. This sharing interface is blocking my view. Now, let us test if our function is actually working. I'm just going to do Python linear.py. If you're using an older Python, you could use Python 3, but we do not have. I don't know why it's not printing anything. Verify the results. Oh, 1 second, I need to remove best Python linear dot hi. Oh, yeah, I'm in the correct place. Give me 1 second. Give me 1 second. Transfer to the list. 1 second, I need to see something. Oh yeah, I don't know what was wrong. I don't know what was wrong, which was causing it not to work, but it's working either way. Found it at position 5, and we can confirm it. 0, 1, 2, 3, 4, 5. Correct. And to see if you put the wrong number, like we do not have 5 here, will this work? Look elsewhere. As you can see, linear search implementation is quite easy if you look at it properly. It's a very easy thing to implement, and I do believe no one can struggle with linear search. Now, let us get to binary search. Binary search, as we said, is just a tad bit more complex. And 1 second, let me move it away from the sharing, let me move it away from the sharing position. Don't want that interface to bug me. There, now that should be okay. Now, binary search is a bit more complex, but as I said before, we won't use any sorting algorithms at the moment. We'll use an already sorted list to do all this. Now, binary search is not as easy as a linear search. Not as hard as other such sorting algorithms, but in such algorithms, it's a bit more complex to get at, and it will need a lot of practice to really master. Now, let's see if I can remember this. Don't worry, Miss Kombuki sana. Now, As normal, we are going to create a function which is going to do our task. We're going to call it binary search. And the search, as normal, will take a list and a target. Now, we have to now know where the first is always be a position 0. We have to indicate the first and the last position. There's something we will need because we said we need to divide it by 2. We need to divide it at the middle point. So we need the first and the last position. So first, you're going to put it at 0 because obviously the first one is at index 0. But the last one will be at the length of the list. If you are at the length of the list, minus 1. People might be asking, why are we saying minus 1? Let's take a list of 5 elements. The length of that list is 5. Yes. But the last index is not 5, it is 4. That is where we minus 1. When you take the length of the list, which is the number of elements in the list, and you minus 1, you get the last index of the list. Now, for this, we're going to do a bit differently. We're going to use a while loop. Now, I do hope you know while loops. So now we are going to relate something. While first is less than or equal to last. Now, you may be asking, where are we comparing if the first, oh, sorry for this. It's a comparison. How is it called? I've forgotten the name, but it's a comparison indicator there. I should not have put the space between the less than and the equal to symbol. Now, why are we comparing first and last? Well, think to yourself, tumeendelea kucompare tukafika somewhere like 9, 10. Then we divide 10 atupate tumelemea at 10 for first and last. What does that mean? What it means is as long as first is always less or equal to last, you're going to run this function. But the second it surpasses like the last index, it literally means that you have not found it. That's why you are starting from first to last. Ienda zinakaribiana, zikikaribiana, zifike the same digit, then zitapitana. First ita exchange position na last. That means hatujapata kitu. That means the while loop will end. Simple. That's all it is. Now we need to compute for the middle position. As I said, binary search, we are going to use the middle position to look for the target value. So what is the midpoint? The midpoint, we can call it midpoint, why not? The midpoint, as you can guess, it is just first plus last divided by 2. Oh, and the 2 slashes means just floor division. And you see 2 slashes means floor. Like 3.12, it will be just 3, 3.23, 4.5, it will be 4. Basically, it just returns whole numbers. That's why I'm using floor division. We do not want to work with the decimal positions here. It's not really what we want to work with. Now, we're going to run an if loop as normal to compare each value we find. Now, if the list at the midpoint, because that's what we need to compare, at the midpoint is equals to the target, what you are comparing to. And now what do we do after that? We are going to return the index of midpoint, the index midpoint, because you've already found it. Well, what if now list at the midpoint now is less than target? If you remember what we said, if you compare with the target, but the target is greater than midpoint, what do? You move to the right side. And how do you do that? Well, if you remember well, we have the first and the last positions. We have them. Now, how do we move this to the right side? Simple. You take the first index and then you change the first variable to the number after midpoint. That is it. We have moved it to the right. If it was 1, 2, 3, 4, 5 up to 10, we have compared with 5, it's greater than. Well, we're going to move the first position from number 1 to number 6. We have moved it to the right side. That's how simple it is. First is equals to midpoint, sorry, spelling mistake, plus 1. That is it. Now, what if it's less? Because obviously that's what it's left. If it's not equal and it's not greater than, it means that it's less. But if it's less, now we're not moving the first now. We're going to move the last position to the number before midpoint. As I said, if it's from number 1 to 10, we have compared with 5, but now it's less than 5. We are going to move the last position from number 10 to number 4. Now we have moved it to the left side of the list. Simple. So last is equals to midpoint minus 1. And there you have it. We have a binary search algorithm with us. What else do we need? We don't really need anything else. All you have to do as normal, write the verify function. Verify. Now this is going to take the index again. And I don't even have to write the entirety of this. All I have to do is copy from linear, because it is just the same thing. We don't really have to rewrite it. Now, our numbers list. As I said before, it has to be ordered. So we are going to use a list of numbers which are in order. It doesn't have to be following each other like this. Inaweza kuwa 22, iwe 35, 35, iwe 44, iwe like 57, iwe like 69, iwe like 70, na iwe like 89. As long as they are ordered from one, hivyo zinafuatana in a certain order, then ikifuatana as in ascending order, 1 to the end, blah blah blah, then you can use excuse me if you're the one with the mic which is on. It's really it's causing out of echoes on my side, and I would appreciate if you turn it off. Thank you. Now, as I said, the list to work with binary search needs to be ordered. Now I know you might, most of the time you're all going to get an ordered list or ordered set of values. Most of the time the values will be disordered. Don't worry, we'll cover sorting algorithms later to learn how to sort them so that you can produce a sorted list like this. Don't worry about it, we will get there. Now that we have number, the result is equal to binary search. Binary search, it takes in the list, which is numbers, and the target, let's look for 57, because it is in the list. And as number, we are going to, don't know what happened before, but to avoid what happened before, I'm just going to print the numbers first, and then I am going to verify the result. Well, it's time to test our function. First of all, I need to clear my terminal. Now, let us test it. As normal, Python binary.py. Would you look at that? It's working. And to confirm it, 0, 1, 2, 3, 4. We have found it. And as normal, to test if it has a number which does not exist, and then we run it, look elsewhere. And there you have it. Simple, direct implementation of linear and binary search. Easy. And the unfortunate thing, this is the easiest part, the easiest class you'll ever have. Functions will not be as easy as this from here northwards. It's better you embrace the easiness of this function you are covered today, and these algorithms are covered today, because next class, which may be this month, end of this month or start of next month, we will be covering sort algorithm, which will be way more complex than this. They will be covering way more harder stuff than this, because like binary search, you need a sorted list. Linear search, you might have just to forget about it at the moment. Linear search, you'll only have to use it in very, very small lists if you have them. Now, a simple class, such algorithms are the easiest algorithms you can learn at the moment. And in my next class, as normal, I will cover sorting algorithms. And then after that, we'll go to the bane of my existence, time complexity and space complexity, which I know many programmers do not hit to and do not really care about. And something I can say, as a programmer, it's very essential you understand these algorithms. After this class, go online, go and study them for yourself. If you need this the files that I've made, so I'm not really deleting them, zitakuwa tu hapa kwa lapi. Kama unataka nitakutumia, uniulize, nitakutumia. I'll make sure it gets to you. If you want the recording of this class, it will get to you. If you want it, I will still advise you, go out there, learn. You can even start sorting algorithms mapema if you are going to join our next class. You can start them early, and then you're going to proceed well. And if anyone has a question, you better ask before we end this session. If anyone has any question. Don't worry, even if you have no questions today, trust me, in the future classes, you will have a lot of questions as you are covering more complex topics. Well, thank you for attending this class. Microsoft is appreciative, is very proud of teaching people skills and impacting their lives as many times, as much as they can. And if you want to join a position like mine where you ambassador for Microsoft, you can go and register for them. Being a Microsoft ambassador, you can join any way, time you wish. Any person is welcome. A few steps, a few registration process, maybe a few things here and there. And I would like to see you join our ranks. Have a nice evening, and I hope to see you in my next class.